Okay, in part B, we are asked when these two solutions react, the sodium chromate and the silver nitrate, what is present in the solution after the reaction is complete? The solid precipitate is not considered to be in the solution. So we're asking essentially what doesn't precipitate? What are we left with in the solution after the reaction goes to its completion? So I've listed what we were given back in part A, the initial volume and concentration for each of the reactants, and I've listed the balanced chemical equation here. So what I want to do is talk through the starting amounts of each. So we already found the starting amount of sodium ion in part A. So if you want to walk through of how to do that, just go back and look at what we did in part A. It's 0.3575. And so based on this chemical equation, then it's 2-to-1 sodium to this chromate ion. So there's half as many moles of the chromate ion that we start with then. And then we do the same thing for the silver and the nitrate. All I did was take this volume, 0.125 liters or 125 milliliters, multiply it by 2.50 molar, and it's a 1-to-1 ratio here of silver to nitrate. So 0.3125 moles of silver ion and 0.3125 moles of nitrate ions. Okay. So without having to show a whole bunch of mathematical stoichiometry, let's look at what happens in the reaction. Silver and chromate react together to form a precipitate, but they do it in there's one chromate ion that reacts with every 2 silver ions. Okay, so they do it in a 1-to-2 ratio. So we have some chromate and a little more silver, but we don't have twice as much more, right? So if I'm going to react 1-to-2 chromate to silver, twice as much as of 0.17875 is greater than 0.3125. So what happens? All the silver gets used up and we're left behind with some chromate, okay? So the ions present will be the sodium and the nitrate ions because they're aqueous in the solution, the excess chromate ion, and the water. The chromate ions are precipitated by the silver ions in a 1-to-2 ratio of chromate to silver, meaning that the silver ions are consumed at twice the rate of the chromate ions. 0.3125 moles of silver ions will react with half as much, right? It's a 2-to-1 ratio. Half of that is 0.156625 moles of chromate ions. Well, we only have 0.17875. So if we react 0.15625, we're left with 0.0225 moles of chromate in the solution in excess. Okay, so we are left with our spectator ions, our excess chromate ions, and then the liquid water in the solution.